Hello everybody, here's Reid speaking. This is a new presentation called A Consciousness-Based Universe. I want to speak about four categories. Category one is water, then second, quantum criticality, and third about microtubules and the research of Stuart Hameroff and Sir Roger Penrose. And at four, I want to unite all that and synthesize the information and make a first walking attempt. Anyway, for me, it's a first walking attempt to define what consciousness could be, what the soul could be, where it is, how it's attached to the thermodynamic body, and what an emotion is, an intention is, and a few other things. And after we have an idea what these phenomena are, we get to the last slide, and there I will try to define what energy is based upon my model that I presented in the other presentations. I'm working with a time and consciousness based model. The time aspect I have already communicated in the other presentations, and now I want to introduce the consciousness aspect. I'm doing this because, from my view, consciousness is a function of time and consciousness, and I've given the concept of the virtual particle flux that emanates everywhere in space, properties that I feel make sense, and these virtual particles are, in my world, logic fluctuations, where a non-dualistic logic to a dualistic logic is fluctuating, creating something literally from nothing, and thereby the virtual particles create everywhere in space the flow of time, and there where we see a mass, time gets structured. Okay, I will walk through these concepts as we go again. And so in part one of the series, I will look at water and quantum criticality, and then in the second video, I will look at 3 and 4 microtubules and what consciousness is. Yes, to get started, or before I get started, I want to point out again my mission statement. I'm mentioning that at most of my talks because I think it's fundamental and most important issue. I want to get the mechanicals to the spiritual side. What I mean by that is we are living in a society where people have mainly a materialistic or mechanical worldview, and this mechanical worldview creates some psychological baseline of deficiency, and that is at the very base or the root cause for many of the big problems that we have. It's also the reason why our economical system is built up the way it is. And when we look today, 2023, at the problems we have with ongoing wars since thousands of years and exaggerated Greek, etc., etc., I don't need to get into that. We all know what the problems are. We need a change in consciousness. It can't go on like that. And we need to catch an understanding what this universe is about. And it's not a mechanical universe that had a beginning. It's a consciousness-based universe that is ongoing since, from my view, an eternity. So I'm trying to create a spiritual awareness via a new time and consciousness-based physics and a technology that supports this approach. On the other presentations on my YouTube channel, Time as a Function of Energy is one video. I'm trying to explain how force is a sign of what energy is from my view. Okay, let's start with water. These pictures here are from a book called The Fourth Phase of Water, written by Professor Gerald Pollack, a book that I can really recommend. And what Gerald Pollack suggests is that there's more than 3 phases of water. We know the 3 phases: ice, water, and steam or vapor. And what Gerald Pollack suggests is that there is another phase of water called EZ. I don't know how to pronounce it in English. And EZ stands for exclusion zone. That means we have here a surface, the gray area here, and this surface is water loving surface, and at a water loving surface the the positively charged protons leave the surface, leaving behind a negatively charged exclusion zone area that can go up to a millimeter in thickness, and this water has a negative charge and the bulk water has a positive charge, and that plays a role in certain situations in biological systems, as I will show just now. Here on the left hand side we have the hydrophilic surface, the water-loving surface. We have the protons being pushed out, that's the exclusion zone, and the water molecules tend to structure themselves into a hexagon structure, and this exclusion zone water has a higher viscosity. However, the water that is further inside, the positively charged water, has a very low viscosity, and here on the right hand side we see also a water loving surface, and after 10 seconds how the exclusion zone is created. So after a few minutes the exclusion zone is created, and what is shown here on the picture is that with this gray area here on the right hand side, these are tiny little beads that were just sort of they are floating in the water, and then when you introduce this into an exclusion zone water, you get this effect of clear water at the surface. And this plays a role in certain situations. For example, when plants want to create space for their growth. We know this effect from mushrooms or from plants. When they grow through a road, they can crack the street with enormous power, and one can wonder, where does the energy and the power come from to crack the concrete or the tar from the street, and that comes from the repelling force of the positive charges towards the exclusion zone of these hydronium ions that we can see here on the left hand side, and and these hydronium ions, they have a very small friction. They are close to superfluid, anyway that's the claim, and Gerald Pollack assumes that this is also an effect that is created between the ice skater, the piece of metal on the ice skater, and the ice, that we have a small exclusion zone water area, and then the positive ions between the metal and the ice, and that creates not only a thin molten area, but an area of very low viscosity, and that's why the ice skaters can move so easily over the ice. The opposing effect is known from ships. When ships move in very cold water, that is just at the point where the ice freezes, the exclusion zone water, the negatively charged water, has a higher viscosity, and when the water is just about to freeze, then it can be that the water is structured, and then the ships have greater problems to navigate through the water. This exclusion zone here, this positively charged area is a thin area, but when the water is in generally very cold, it starts to get structured, and and just before it gets structured, it becomes an ice. Here we see that we have here on A we have ice, and there we have a transition. The positive charges are leaving, and then we have exclusion zone water. That's the structured water, and that can make it difficult for ships to navigate in exactly the same way as they usually do. Here is an interesting effect that happens when water changes its phase, for example, from a liquid state, from a already structured state, exclusion zone water, into solid ice, and there we see an energy release in the form of infrared radiation, and that is related to, well, according to Jerry Pollock, that from thermal fluctuations, from energy that is stored in the water by thermodynamic means. And I will elaborate now several times in this presentation that I do not, I assume that there might be a different effect for it. It might not be thermal fluctuations or thermal energy that gets released, but quantum fluctuations. And I think I have an argument here. I will show that the hydrogen bond oscillations in water are also driven by quantum fluctuations, and when water changes its phase, it also includes a quantum critical phase transition, and thereby energy from the 0-point energy, meaning from the quantum fluctuations, is released, and that creates this infrared flash on that we see here on the right side of the here in the chart. Here up here we have liquid water that has about 3 or 4 degrees minus Celsius, and down here the last picture, the fourth picture, is also this blue spot that is ice, also at -3 or -4 degrees minus. And when water below 0 degrees Celsius turns into ice below 0 degrees Celsius, during the transition from liquid to ice, there is a infrared flash being released, and that is shown here on the right hand side as a scale of heat. One must be careful, this is not necessarily heat, because the infrared spectrum is quite a large spectrum, so it just relates to infrared radiation, and it cannot directly be translated in a heating of above 1 degree Celsius as is suggested here. It just shows that light in the infrared spectrum is released, and from my view this comes from a quantum critical phase transition. So this is not thermal energy that is released. I assume it is energy from quantum fluctuations, and as I go through this presentation I will try and show several examples for that, or further examples that support this idea that we are dealing here with an energy input from quantum fluctuations. Here's an interesting effect with water. On the left hand side we see Erasto Mpemba, a guy from Tanzania, and he wanted to sell ice cream in school, and because electricity is not so easy to find on every corner, he tried to freeze his ice cream as fast as possible, and not having any knowledge about physics and thermodynamics, he just took a glass of hot water and a glass of cold water and put it into the freezer, and he realized that the hot water freezes faster than the cold water, and this effect is today known as the Mpemba effect. The effect was discovered several times in the past. You can see that at Wikipedia. It's quite interesting, and there's still ongoing research about that effect, and this effect does not always show up. The conditions have to be right, but under certain conditions this effect exists, so there seems to be no doubt about it. And now there are several theories on why this happens. Some say hot water releases in a quicker way its steam, and that might support to reducing the volume and supports the cooling and so on. Anyway, I don't want to get further into that. I found no explanation that sort of really convinced me. That's why I will give my version of that. And first of all, I want to describe what is shown here in the picture on the left top side. From my view, we are living in two universes at the same time, created by two different types of virtual particles emanating from their own frame. one type of virtual particle. These are the thermoclassical fluctuations creating the thermodynamic flow of time that determines the quality of our reality and the speed of light that we know, and so on. And then when we cool down systems and we get rid of the thermal fluctuations here to 0 Kelvin, we see that reality changes completely. And that tells me that reality is driven by a different type of virtual particle, and that the flow of time that is created by these virtual particles unfolds in a very different way. So we're living in two universes at the same time. And to get access to these quantum fluctuations, to the 0-point energy, we have two options. One option is, as I just mentioned, to cool down the system to very cold temperatures. And the other option is a so-called quantum critical phase transition. And the Debye temperature is the upper temperature level where quantum fluctuations can still have an effect on the phase transition of the material. I'll give you an example what the Debye temperature means in simple terms. If you have a material at 0 Kelvin and you want to heat it up to 10 Kelvin, you need a small amount of thermal energy. And the reason why you only need a small amount to do that is because from 0 Kelvin to 10 Kelvin, quantum fluctuations are helping to heat up the material. And so from 0 to 10 Kelvin, you need only a little bit of thermal energy to heat it up. When you go now from 10 Kelvin to 20 Kelvin, you need a bit more thermal energy, because now in relation the quantum fluctuations are helping less with heating the material. And then you go from 20 Kelvin to 30 Kelvin and so on, and it gets more and more. And at some stage, this becoming more of thermal energy sort of flattens out in a graph that is a curve that doesn't get higher anymore. And when the increase in thermal energy does not increase anymore, then you have reached the Debye temperature. And for many materials, the Debye temperature is above room temperature. That's the interesting part. So I assume that water is a quantum critical material par excellence. The literature does not say that, but I assume that this is so. Water, especially up to 37 degrees Celsius, that's the blood temperature, seems to efficiently integrate energy from the quantum fluctuations, and above 37 degrees Celsius in a less efficient way. I will show later on other arguments that support that idea. So the reason now why cold water is freezed in a more difficult way than hot water is that at cold water at 25 degrees, for example, the 25 degrees water has a better access to quantum fluctuations. So these quantum fluctuations help to hold upright the temperature of 25 degrees. That's what we see. And now if we want to cool down 25 degrees water, we have to go against the strong input of quantum fluctuations. That's why we need more energy to cool down 25 degrees Celsius water and freeze it than 90 degrees Celsius water, because 90 degrees Celsius water has less access to the 0-point energy, and that's why it's easier to cool it down. Now when you cool it down, the 90 degrees water must move through the 25 degrees Celsius water. However, it falls through this temperature, so to speak, because water has to be for a certain while at a certain temperature so that the quantum fluctuations can do what they want to do. We see that in the quantum paraelectric strontium titanate that is pumped with a 790 nanometer laser. I will get into that, and so the picture fits together. And we also have the inverse Pember effect that shows that 25 degrees water heats up easier than 90 degrees water. That is because, again, quantum fluctuations are acting in a stronger way at this colder water and in a less good way at 90 degrees. So the heating is, you have the inverse Pember effect, and that would also support this view that I just explained here. Okay, I will just leave it at the point. I just want to point out another few interesting phenomena that seem to exist with water. Here again, and later on I will put the picture together, as I said. Okay, what we see here is a tube that has on the inner surface a water-loving surface, and at that towards that surface we have again this EZ water, the exclusion zone water, that has a negative charge. The positive charge is in the middle, and it takes a few seconds, a few minutes until that is developed. And what Gerald Pollack claims here in his book, I hope this is reproducible, that fresh water, you have to give it a little push, that fresh water is flowing in here, and the fresh water that flows in here had less time to get structured on the inner surface than the water that is inside here. And inside you have a higher exclusion zone, and this exclusion zone has the positive charges on the inside and the negative charges on this at the surface, and they repel each other. That's why you have an electrically repelling situation here, and that pushes or sucks out the water out of the tube. And once you put such a tube underwater and give the water a little push in one direction, you will get apparently a steady flow of water. And this is sort of a pretty a flow that has a perpetual characteristic, not to get confused with perpetual motion. That of course does not exist. Perpetual motion is a closed system, and anyway closed systems do not exist, but we have processes that have a perpetual characteristic. That is something very different. And anyway, so this seems to be a continuous flow. And what Gerald Pollack is suggesting is that the energy for this process comes from the environmental ambient heat. And that might be the case. However, I want to mention that this might not be the case. It could be, again, quantum fluctuations that are doing the job, because water is, from my view, a quantum critical material that integrates permanently energy and information from the domain of quantum fluctuations, and thereby water is actually a free energy device. The energy input is small, but it is there. And anyhow, what an interesting effect that they are mentioning here in relation with that is that you have red blood cells that have a size from 6 to 7 micrometers, and some capillaries do have a diameter of only 3 to 5 micrometer, and these red blood cells can be squeezed through these capillaries by brute force, so to speak. And what is interesting is that there seems to be almost no pressure drop across the capillary bed, most of the drop occurring over the relatively larger arterioles. Thus, capillaries do not behave as the high resistance conduits we expect. Some energy could assist the heart in driving the flow, and that energy could easily come from the radiant energy that your body absorbs. And that's an interesting idea, that energy from radiant energy, or from 0 point energy, as I believe, helps the heart in pushing the blood through all these little capillaries. Would make sense. Would also be an explanation how trees can suck up water to many tens of meters against the gravitational force, and that is also an enormous energy input that is created there via the capillary function in the trees. And found that an interesting effect. Here in the middle we will see another effect, and that is very interesting to me. What I want to point out here is that water is generally electrically active. We have here 2 glasses of water, and in the glasses, what we cannot see here on the picture are 2 electrodes, and on these electrodes is a high voltage. I'm not sure how much it is, but I think it's a few hundred or a few thousand volts. And if you put that voltage up, you get a stream of water. There's a water bridge being created between the glasses, and they can have a distance from even 2 centimeters. So water can get solid-like, let's put it that way, under the influence of an electrical potential. And we find these electrical potentials in the nanometer and even micrometer range in the body, and thereby water can locally become sort of a little bit solid, and water can thereby push other biomolecules into a certain direction at a certain point in time, and water becomes its information and energy from quantum fluctuations, not from the thermal fluctuations, and that controls the positioning of amino acids when it comes to the protein folding process, but I'll get into that a bit later. And what we see here is just a really beautiful example for the stiffness of water and how it can react on the electrical field. Yeah, here's the mRNA folding process, and there is an interesting phenomenon in relation with that. It's called the Leventhal paradox, and here at the Simon Fraser University they have this comment here: if the polymer doesn't search all of conformation space, how on earth does it find its ground state in a reasonable time? So that relates also to these to the mRNA. We have here on the right hand side a picture of a cell. The nucleus, the DNA, it splits up into an mRNA strand. The mRNA strand moves outside of the cell, connects to amino acids, and then this strand folds together into protein. And this folding process is the issue of interest here, because there are many possibilities of how you can fold together this RNA strand. And the question is now, how does nature find the right way how to fold the protein, and why does it do it in such a small, in such a fast way? I'll just give you one example. There is one protein called a 3-stranded beta sheet. And this beta sheet contains up to 90 amino acids. That's nothing too big or small. That's an average protein. Other protein and the possibilities of how it can fold to a protein is 10 by the power of 90. Some proteins have possibilities of 10 by the power of 300. It's just a ridiculously high amount. Now, what does 10 by the power of 90 actually mean, just to get a picture of what the size of this figure is? In the today's visible universe, we have 10 by the power of 80 atoms. So I think everyone will agree that's a hell of a lot of atoms. Anyway, the amount of possibilities to fold together is 10 by the power of 90, so it's even more. And so let's say we are living in a purely thermodynamic driven universe where everything happens by coincidence. That would mean, the nature has to try and find the right way of how to fold this together, and then by coincidence there is this one option, and that option is then taken. So let's say that mRNA strand is making 100 billion experiments per second to search its right way how to fold together. It would still take longer than the age of the universe to fold in the correct way. And anyway, in reality, this protein needs only 140 nanoseconds to find the right combination. So now, from my view, this means this is no coincidence. The mRNA strand somehow knows how to fold together in such a short time into the right protein structure. And now the question is, who tells the mRNA strand to fold together in the right way? Part of the answer is already here in the headline of the MIT Technology Review paper. Here, water solves protein folding problems. So the The information comes from the water, and the water is a quantum critical molecule. So the information that tells the water how to fold the protein probably is in the matrix of quantum fluctuations. That's where we are going now with this presentation. And what I see here is that the domain of quantum fluctuations, that's where the master plan is for a lot of things. Okay, this is another example for the mRNA folding problem. Issue here is paper, water, and proteins, a love-hate relationship. I will quickly read the text on the left-hand side. The aqueous environment thus has a more active role in protein dynamics and stability than what is traditionally imagined and may have many applications. Moreover, the common hydrophilic nature of the interfaces of protein-protein and protein-DNA complexes and the abundance of water molecules at the interfaces suggest that water is indispensable for biomolecular recognition and self-assembly. Now what we see here on the right hand side, these blue and gray and light blue spheres, these are water molecules, and these red and orange and this purple line here, these are proteins, and this is a DNA strand. Here in the water at the protein-protein and protein-DNA interfaces, the complex of bovine papilloma virus 1E2 with DNA and so on contains 241 water molecules represented by the spheres, of which 40 water molecules mediate protein-protein interactions, these are the blue spheres, and another 42 water molecules mediate protein-DNA interactions, these are the light blue spheres. So the water, by creating in a very fast way electrical potentials via quantum fluctuations, they determine when the water molecules create a conductor for protons. That's an electrical wire, so to speak. They determine when they create a certain stiffness at a certain point in time. So the water molecules are pushing this mRNA strand and DNA strand at the right time, at the right position. So these are like the people who built the house. They are the construction workers, so to speak. So the construction plan is mediated via the water molecules. And it goes on. The complexity is even higher. So how to fold together a protein is a complex issue. Okay, what we see here on the right hand side of the picture is a flagellum motor. And here the question is now, how are these proteins positioned at the right time into the right position? We find these chemical motors, which are actually electrical motors, in flagellum, in cells, in bacteria, and in sperm cells. And the interesting thing is, how are these motors built up? Because there are two problems. One problem is the issue with irreducible complexity. If there's one part missing, the motor will not work. And also the steps of what proteins are put together is a complex thing. So there must be somewhere a construction plan that tells the proteins at what point in time they are positioned where, and this information comes from the water. I will read out here on the left hand side. The study by Papoyan indicates that water not only induces protein folding and binding, but also actively participates via long-range water-mediated contacts. Both hydrophobic and hydrophilic effects are dominant driving forces for biochemical processes. And now let's have another look at the motor here on this picture here at B. We can see the internal structure of the motor. This is the rotor that rotates, and this is in a one could call it a kind of electromagnetic bearing that is has an extremely low friction. These engines can turn with 100,000 RPM, and they can stop and change the direction of rotation within one rotation. So that's extremely efficient and extremely fast. And just by looking at these pictures here, one can see the amazing complexity and organization of these motors. And so anyway, what I'm saying is, or assuming, there must be a construction plan of how to build up these motors, and that cannot evolve, from my view, by natural selection or as Darwin has suggested it, and or by the thermodynamic principle of coincidence. So here is another short
Some bacteria contain flagellum, which are long filaments that protrude from bacteria, seen here using electron microscopy. These filaments are attached to large protein complexes called bacteria flagella motors that can rotate and allow bacteria to swim towards or away from substances in a process named chemotaxis. Compared to the well-known membrane proteins, G-protein coupled receptors and ATP synthase, the bacteria flagella motor is very large, measuring around 45 nanometers in diameter. The rotor of this motor is comprised of multiple rings. The first to assemble is termed the fly-F ring, which acts as a scaffold. Onto this, the fly-G ring forms, which is responsible for switching the direction of the motor, causing either runs or tumbling. Finally, we have the fly-M and fly-N rings, which may regulate the switching of the motor by external stimuli. The rotor spans the inner and outer membrane of the bacteria. However, like all motors, torque generation cannot occur without a stator. Upon engagement of this stator, protons travel through the complex and generate rotation.
Okay, well, that was a short video about the flagellum motor, and we just go on with other phenomena in relation with water. Here I will read out: the formation of DNA copies was triggered by the ambient geomagnetic electromagnetic force background of very low frequencies related to the Schumann resonances, specifically in the 7.8 Hertz band. In humans, psychological rhythms and global collective behaviors are not only synchronized with solar and geomagnetic activity, but disruptions in these fields can also invoke adverse effects upon human health and behavior. I find that interesting because it's often claimed by spiritual people or religious people that the earth has its own fields and consciousness, and that these fields have an influence on human behavior. There is, for example, this phenomenon of spontaneous dancing. There is one example somewhere in Africa where people in a city suddenly started to dance. All people in the city, no one knows why, and everyone is going completely wild from 1 minute to the next. The whole thing lasted for a few minutes, and then the whole thing was over. So there are sometimes phenomena coming up where the human behavior is totally changed, and sometimes it's really hard to see what the cause is, and there are unseen causes that are transmitted by electromagnetic fields that come from the earth or from solar activity or whatever. And so these effects, from my view, are transferred to the water molecules, to the quantum critical nature of water molecules, and they transfer this information to the biomolecules and to the brain cells and so on, and create this change in behavior. Here's another pretty remarkable statement by um, Luc Montagnier. He got the Nobel Prize in Medicine in 2008 for discovering the HIV virus. And he makes a pretty remarkable claim here. If you take an electromagnetic coil and you run just an electric signal, creating a magnetic field through it, and it's a low frequency, for example, a few hertz, and you place two glasses of water here, and one glass has water and the DNA of a certain animal or human or whatever, and the other glass of water is just pure water, then you create and you place these two glasses next to each other, and then a magnetic field, an electrical signal, is put through this coil for a while. Then after some hours, that other water, the other glass of water, will get an information imprint of the first glass, and thereby you can transfer the information that is radiated from the DNA to the water in the first glass, and this information is then transferred to the water where there is no DNA inside. So the water molecules, the oscillation, the oscillatory pattern of the water, which is extremely complex, gets the signature of the first one. And in the next step, what that has led to is that they are suggesting that you can transfer medication via telephone. So on one side of the telephone, you have the glass of water and an magnet, and you put that glass with, let's say, an aspirin into that first coil, and you let it run for a while, and then you have a telephone connection to somewhere else, and there you also have a coil with clean or pure water, and then after a while you are transferring this electromagnetic signal to this side. The water becomes the oscillatory pattern of the first one, the transmitting one. Now what happens here in my view is that via the electromagnetic field also captures the pattern within the domain of quantum fluctuations somehow that is not seen in the device. And this electromagnetic signal, which has an imprint of quantum fluctuations, is transferred to the other side, to the other telephone, and there after a while you need to pump it for a long enough time. Then these water molecules do receive this information not via an electromagnetic signal. The electromagnetic signal is just the mediating, the carrier signal, so to speak. But here we get an imprint in the quantum fluctuations, and the quantum fluctuations determine the oscillations on the hydrogen bridge, and these oscillations are stable in time because the domain of quantum fluctuations is a superconducting and superfluid domain. If it was a thermal or electromagnetic oscillations, only the patterns would entropize straight away, and water could not keep or store information for a longer time. It's done via quantum fluctuations. However, that's not held there forever, of course. How long it keeps this information, I do not know. But there's quite some interesting research on that going on, which was done by Luc Montagnier and his team, and there seems to be something to it. So the bottom line is, or the only thing what I want to point out is that information can be transferred to water, and water can keep that information for a while. And I share the opinion that this is not the imprint of this oscillatory pattern is not stored in the electromagnetic or thermodynamic domain. It is stored in the domain of quantum fluctuations. Okay, this is part one. I just want to do the conclusions about water. Water absorbs electromagnetic frequencies of a broad spectrum that influences its oscillatory imprint. I think there's enough information that supports that. And then this oscillatory fingerprint of the water influences significantly most biochemical reactions. I think that's also clear. So I'm coming to the conclusion that it's not the DNA, it's not the mRNA, and so not the proteins, it's actually the water. The water is running the show. The water is controlling how the DNA is doing what at what point in time and so on. And so the next question is, how does water store its frequencies patterns over time? Where does it do it? And who is telling water how to construct these very complex structures? So by that, I want to get into the topic of quantum criticality. And I want to point out now a few things that are necessary to understand to get the whole picture. Here on this slide, I want to briefly explain what a broken symmetry is and what a broken symmetry does, because it is most fundamental. Here on the left-hand side, it's just, let's say, a thin lake of water, a stripe of water representing the virtual particle flux, which is chaotically in space. There is no order, and the virtual particles contain energy for a short time, then they take it with them again when they disappear, and during their short time of existence, they produce that, but we don't see anything of it. And the reason why we don't see anything is because this energy is distributed in a symmetric way. It's like a diver underwater. If a diver dives 10 meters underwater, the water pressure is there. There's a lot of energy there, so to speak, but we don't feel the pressure because it is distributed in a symmetric way. And if we want to make the water pressure underwater and observable, visible, we need a measuring device, and that includes a pressure gradient, and a pressure gradient is comparable to a broken symmetry. So broken symmetry makes something virtual into something observable, and that is most fundamental. Now, these virtual particles, in my view, create the flow of time in space, and there where we see a mass, the flow of time gets structured. So in my world, mass is structured time, and that is represented here on the right-hand side by a waterfall. There's also this beautiful example of I forgot the name of the guy now. When you look at a waterfall from far away, you will see a static white stripe that is comparable to the static view that we have about mass. When I look at my table here in front of me, it looks static, it's non-changing. However, when I get closer to the waterfall, I can see that the waterfall is steadily recreated right now in time by this ongoing virtual particle flux. And the same with the table. When I zoom in with a good microscope, electron microscope, then I can see that atoms are not standing still. They are made out of the field, and an atom, elementary or not, a particle elementary or not, is not a static thing. It is a process, and we have to think in terms of processes, and mass exists as the structural quality of the field. So we need to work with a model that explains what the field is, not that mass is a material thing with a sharp surface. We are dealing here with processes, we are dealing with fields, so we need to have in mind a picture what the field is. And here Professor T.D. Lee, he got the Nobel Prize in Physics, I think 1957 or 58, and he says here, since non-observables imply symmetry, any discovery of asymmetry must imply some observable. This concept of a broken symmetry, converting something virtual into something observable, is a most fundamental and most important aspect, and I will refer again and again to this concept because it's at the base of my time and consciousness based theoretical view. Here we have a slide that comes from another presentation, I think from my first presentation, Energy as a Function of Time. Just want to point out again that we have here the virtual particle flux. There are two types of virtual particle. Here in the picture I'm only showing one type of virtual particle, the so-called thermal or classical virtual particles, and they create the flow of time and space. So the virtual particle flux even between the galaxies and planets are creating the flow of time and space. And there, where we see a mass, this flow of time gets structured. So mass is permanently and newly created in time, meaning in the present. So our whole reality is created from nothing, from empty space right now at this very moment. And why do I say from nothing? Because these virtual particles are logic fluctuations from a non-dualistic logic form into a dualistic logic form. What I mean by that is also in another presentation of mine on our website. I think I'm getting into that also, energy as a function of time. So the virtual energy density at every point in space is unlimited. And why do we not see that? Because this energy is distributed in a balanced, meaning in a symmetrical way. And there where we see something, this symmetrical energy gets structured, meaning it's put into an asymmetric condition, and then via the broken symmetry, these virtual phenomena become visible. And Stephen Hawking has a view that is quite similar to mine, actually. I just want to read out his comment. There are something like 10 million, and so on, one with 80 zeros afterward, particles in the region of the universe that we can observe. Where did they all come from? The answer is that in quantum theory, particles can be created out of the energy in the form of particle-antiparticle pairs. But that just raises the question of where the energy came from. The answer is that the total energy of the universe is exactly zero. The mass in the universe is made out of positive energy. However, all mass is attracting itself by gravity. Two pieces of mass that are close to each other have less energy than the same two pieces a long way apart, because you have to expend energy to separate them against the gravitational force that is pulling them together. Thus, in a sense, the gravitational field has negative energy. In the case of a universe that has an approximately uniform space-time, one can show that this negative gravitational energy exactly cancels the positive energy represented by the mass. So the total energy of the universe is zero, and 2 times 0 is still 0. This means that the positive and negative energy in the universe can simply be doubled without violating the law of energy conservation. It is said there is no such thing as a free lunch, but the universe is the ultimate free lunch. And so we have the steady creation of reality from nothing via this virtual particle flux. And in the end, when we need if we want to have a complete physics model, we have to address the Big Bang, or whatever that was. Did the universe have a beginning? How if the universe had a beginning, at that point something was created from nothing. So in the end, we will not get around a model that explains how to make something from nothing. What physicists are doing today is they take out the fillet piece, so to speak. They start after the Big Bang, and then they say, well, since then energy is conserved and we have the entropizing of energy during the work process, and that's it. And that makes sense. Well, that's correct, but that just ignores the fact of the Big Bang or the creation of something. And it also ignores what a border is, because we have a border between something and nothing. And when you zoom into the borderline, then you will find that the oppositions are identical. So the nothing domain and something, they have something in common. So that means that nothing, in the sense of being nothing at all, is a concept that does not exist. And from my view, nothing is not nothing. It is the presence of non-dualistic logic, because the nothing domain is a logical concept that is non-dual in its nature. So we first need the non-dualistic concept of logic before we think ourselves into the nothing domain. And that is a possible approach how to explain how something can be made from nothing. And in my world, something can only be made from nothing. It is not possible in any other way. Anyway, I'm going into that topic, or I'm speaking about the topic in that other presentation. energy as a function of time. Okay, now what does quantum criticality mean? We are living in two universes at the same time. One universe is the universe that we can see, that our atoms are made up of. We have E is mc square, we have entropizing work processes, and so on. That's the thermodynamic universe created by these classical fluctuations. And then when we cool down a material to close to 0 Kelvin, we can see that the energy is first of all not disappearing to zero. We cannot reach that 0 point. There is a rest energy left over, and this rest energy is created by a different type of virtual particle from my point of view. And since reality can become superfluid, superconducting, and have a non-local aspect, the Bose-Einstein condensate, that tells me that there is another reality that is totally different from our reality, and that's why I believe we have in space two types of ethers. So, and these ethers are created by two different categories of virtual particles emanating from their own frame, and they create their own flow of time. Reality is always determined by how the flow of time unfolds into an observable. And so we are living in two domains at the same time. And the so-called quantum critical phase transition connects these two realities. And the interesting thing is, we know today the decisive difference between a biological living system that shows the phenomenon of self-organization and so-called dead molecular arrangements, and the difference between a life form, biological life form, and a dead molecular arrangement is the quantum critical phase transition. So quantum criticality makes dead molecules alive, and that's how information and energy is transferred to these water molecules. And I will go further now, step by step, into that topic. Here on the right hand side we have a chart from a very interesting paper. I recommend to read that. Also in relation with quantum paraelectric perovskites, strontium titanate, and that's a material we are working in our research. There's some good explanations about how why strontium titanate is a quantum paraelectric, and what it does. Now here we have the temperature line, the x-axis. Here is 0 Kelvin, and when we cool it down, the quantum fluctuations dominate. And when quantum fluctuations determine the phonons in a material, then the phonons can pair the electrons by brute force, so to speak, and then the material can become superconducting. And however, when you go from 0 Kelvin upwards, there is a certain temperature, that's the Debye temperature, where you have thermal fluctuations and quantum fluctuations acting at the same time. And if you are at non-zero temperatures and the material is in a phase critical condition, and these two phases are tuned onto the phase critical point, then you only need very little energy to switch the phase in the crystal, for example, or in water, from phase 1 to phase 2. And when quantum fluctuations determine when and how this phase change is done, then we are speaking about a quantum critical phase transition. And these materials behave totally different. They can show the phenomenon of self-organization and consciousness, and they have access to the quantum fluctuations, and I assume that our souls exist in the domain of quantum fluctuations. So what I have written here, a quantum critical material contains at least two phases that have differing properties. These two phases can be changed from one phase to the other, driven by quantum fluctuations, not only by thermal fluctuations. That's the important point. And here we have the famous quantum critical point at 0 Kelvin. And but that doesn't mean you only have a quantum critical property in a material at 0 Kelvin. There's a quantum critical region, and that can be pushed right even above room temperature on certain materials. Now, what happens to a material when it is cooled down to very cold temperatures is shown in this video. So now we are cooling down a material to very cold temperatures, and as it gets colder, the gas atoms are moving slower and slower, and the wave function becomes bigger and bigger. And once you are reaching a very cold temperature, you are creating a Bose-Einstein condensate. So the atoms they unite. So the reality is not as dual in its characteristic as before. Thermal fluctuations create dual reality, and when the thermal fluctuations are gone, you have everything united in its wave function. I mean, reality still exists, but it exists in a totally different form. And I found that just intriguing, and that again just supports the view that we are living in two universes at the same time. And when a material is totally driven by quantum fluctuations, things just change. Okay, now I want to continue and point out some other aspects with water, so just that the quantum critical nature of water becomes more clear. Here on the right hand side we see a little picture. I'm showing that often we have thermal fluctuations and quantum fluctuations, 0-point energy, and and QC stands for quantum criticality, and there is an overlap, and quantum criticality is merging both universes. It's getting both, connecting both universes together. So life forms and quantum critical materials have access to quantum fluctuations, and then they can show the properties of self-organization, superconductivity, superfluidity, if the phases and so on are also adjusted in the right way. So let's have a look at water. Here's an interesting comment. Energy is constantly produced in the cell, and this energy is partly converted into vibrations of all cellular components, in principle in the lowest energetic state possible. However, the cell is also influenced by quantum fluctuations, also called zero-point energy. A relation between coherent states of water molecules and quantum vacuum zero-point energy electromagnetic fields has been proposed. In principle, this field activity can excite all cellular components by resonance. Long-distance influence in protein folding, as described by us, is an apt example. So here they're also suggesting that the water molecules, the frequency pattern is hold upright in time and created and changed by information and energy coming from the zero-point energy. And my argument is going into the direction that water is an intelligent material. It is conscious, and it becomes its consciousness from the quantum fluctuations. Down here we have another comment. Although the Eigen and Zundel species, these are different states of water, of structured water, just look it up at Wikipedia, still appear to be dominant motives. Quantum fluctuations result in rather drastic events where both transient auto-ionization and delocalization over extended proton wires can simultaneously occur. So water can create so-called molecular chains. These chains function as proton wires, mean like a copper wire for electrons. You got a proton wire that is just a wire for an electrical charge for ions. And they can create ionization and delocalization effects. So water can do quite a lot. They can influence biochemical reactions. It's just running the show. It's the running the chemistry in the border and in the body, and life as we know it on Earth usually, well, I think always contains water. Here we have on the right hand side two graphs from the Stanford University Markland group that quantum effects can weaken the hydrogen bonds, and then you have other situation where quantum fluctuations can strengthen the hydrogen bond. So the information coming from quantum fluctuations determine when, where, what water molecules are connected into a team, and when the team is separated again. So the quantum fluctuations are that influence these hydrogen bridges. They determine how water behaves. So the master plan for constructing our body is in the domain of quantum fluctuations. It's not even in this universe, in this domain. It's in the quantum fluctuations. and water can absorb that information from the domain of quantum fluctuations, and then the water molecules tell the other biomolecules what to do at what point in time. Here on the left-hand side is an also interesting comment. It has been shown that electromagnetic fields affect both the degree of entanglement and indicate that the coherent quantum entangled wave function exists. A striking finding tackled the observation that life systems, as studied in 550 biomedical articles and 80 reports about entanglement and superconductivity, showed distinct electromagnetic frequency patterns. This strongly suggests that coherence, entanglement, and superconductivity may be prerequisites of life. And since entanglement and superconductivity is created by quantum fluctuations, it's clear life and the access to quantum fluctuations via a quantum critical phase transition is fundamental for life. Here on the right-hand side, we have again a picture from the book by Professor Gerald Pollack, The Fourth Phase of Water. This is a glass of water in a very dark environment. And this glass of water will radiate light, photons, like a torch. And it's a perpetual torch. It has a perpetual characteristic. However, the light is so weak you cannot see it with the naked eye, but you can measure it. And what Gerald Pollack is suggesting is that energy is stored in the water by radiant energy, and since we have some ambient radiant energy always around it, it converts this thermal or energy into light. Regarding the point, regarding the nature of the energy source, I do not agree. I assume that water taps energy not from the thermal radiant energy, but from the quantum fluctuations, from the 0-point energy. And this 0-point energy is converted into light, and that is where the water gets actually its energy from. Here on the left-hand side, I want to read out that comment. Here we show using state-of-the-art techniques that allow for quantum mechanical effects in the motion of the electrons and nuclei, that room temperature water, that is very important. Room temperature water is not simply a molecular liquid. Its protons experience wild excursions along the hydrogen bond network driven by quantum fluctuations, not by thermal fluctuations, which result in an expectedly large probability of transient auto-ionization events. The comment on the right-hand side I will not point out. I just explained it briefly, and so let's just have a look at the next slide. Now, here on the left-hand side, we have the water-loving surface, which creates the easy water layer, which stands for exclusion zone. And here Gerald Pollack has placed an electrode that is inert. And here a bit further away, we have the protonized water with a positive charge, with also an chemically inert electrode. And he gets a small electrical potential difference and electrical power from that light bulb. I mean, there is no light bulb. That would be the future development. The power that is getting out is in the picowatt or nanowatt area, so you cannot power a light, but there is a potential difference and a very small electrical current running. What we see here in the middle are two Reid cells. We called them in the past crystal cells. I initiated that research project in 1998, and since 1999 I have crystal cells or Reid cells that are working under permanent load. That is now 24 years. They are also dead short resistant, and they can power an LED in a not such a bad way. It's clearly visible, the light here, and it's about a milliwatt that is given off by these two cells. One cell has about 330 grams, including the aluminum container. There's a presentation on our website about the crystal cell, which was also done in 2023. that gives an update of how these cells are manufactured and what the measurement data is. And there's one, just want to pick out one interesting effect from these cells. The cells contain a polycrystalline silicate, and that silicate contains water, and that's chemically bound. Anyway, the water content is really critical so that these crystal cells work. And what we have here on the right hand side is a chart of these crystal cells, and here we are cooling down a crystal cell from about 39 degrees Celsius to 26 degrees Celsius. This is the temperature curve going down, and this is the temperature going up again to 39 degrees. Now, what we see here, when we go from 39 degrees down to 26 degrees, and here we have the voltage on the crystal cell. That's the voltage under a resistor. I think 1 or 2 kilo ohms were taken here. It's quite a few years ago that we made these tests. Anyway, what we see here is that these cells, they work well from 10 degrees Celsius up to exactly 37 degrees Celsius. And above 37 degrees Celsius, the power curve is not developing as one would expect. So here we are dropping the temperature over a time frame of several hours, so the voltage curve follows the temperature curve more or less. And now we are heating it up again from 26 degrees through 34 and 37 degrees here up to 39 degrees. So here also the voltage curve follows exactly the temperature curve, and it should continue in normally if it was a linear graph, but it does not. There's a first cut off, an interruption at 34 degrees Celsius, but then it recovers. It takes a while, as if there is another resonance frequency towards the quantum fluctuations. And then from 37 degrees onwards, here the curve starts to flatten out again, and then there is no recovery of that curve at all, even in time, a longer time after a few hours. So there it's game over. So so that's interesting. So this suggests is that the water molecules are channeling energy from quantum fluctuations in an efficient way at cold temperatures, and that goes up to 34, and then especially there's a final cutoff at 37 degrees Celsius, and from then on it doesn't work well. And there are animals that have a blood temperature of 39, I think even 40 degrees Celsius, but not warmer. And maybe there is a temperature-wise resonance frequency to quantum fluctuations, so to different levels of master plan, how, because the water can control certain protein folding processes at certain temperatures in a better way or less good way. And that's why certain animals have, or categories of animals have certain temperatures. And so on one hand, these cells are extremely sensitive to temperature. You reduce the temperature from 39 degrees Celsius to 26 degrees Celsius, and you have a dramatic fall in power output. And there is a doubling of power for every 4 degrees Celsius in the Reid cell. So that's why we assumed, it's clear that cell is converting the ambient heat. Not like a Seebeck or Peltier effect where you need a temperature difference, but it's converting the ambient heat into electrical current because it is so ridiculously temperature sensitive. So then Eckhard Kantz made many extended and highly sensitive colorimetric experiments that were repeated again and again. We had a statistical overlaying of these experiments, and there is we know exactly how much it must cool down when we have a 1 kilo ohm resistor running about 1 milliamp, meaning 1 milliwatt. And after 4 hours we have that amount of cooling. But there and the measurement was by far sensitive enough to make that visible, but there is absolutely no cooling down when putting these cells under load, and there's also absolutely no heating up, and that suggests that the energy from these cells is not related to thermodynamic energy, meaning from radiant thermal oscillations, and or radiant energy that creates these thermal oscillations. The part of the oscillation of the water molecules comes from quantum fluctuations, and these quantum fluctuations, they deliver the energy. So here we have another observation that supports this idea. But of course, if it is so, we don't know. It's just an idea that I have here. Here's another experiment by Roberto Garamano, which I met at the water conference also at the in Bulgaria in 2014, and he has made an experiment with distilled water, and he has these water-loving materials here in the water, and two wires which are the same, and he creates can see a steady electrical current from that, and he assumes that infrared radiation is converted into electrical power. Regarding this comment now, that this might be infrared power, well, one needs a colorimetric experiment to verify that, and that is not there. So I do not assume that infrared radiation is converted here in his experiment into electrical current. What he's getting out is 0.2 microwatts by B distilled water, and so he says, although it is a totally new phenomenon, it should be noted that not negligible electric power is obtained. So this is a very interesting experiment that supports also my experiments and other experiments by Jared Pollack. And however, I assume that we are not dealing here with infrared radiation. I think that the infrared radiation or this thermal temperature at 37 degrees Celsius and below room temperature 25 degrees Celsius, that is a resonance frequency for the molecules, for the water molecules, to get access to the domain of quantum fluctuation. So the temperature is not is not the source of energy. It just creates an environmental condition so that the water molecules can get access to the quantum fluctuations, and that's where the energy input comes from. Here's another interesting experiment with red light LEDs, which have a small band gap. Again, red light. It starts at turquoise light, goes down to red, and then into the near infrared, maybe into the far infrared. There is this door that where things can resonate to the quantum fluctuations. If you go higher up to the blue and then to the ultraviolet, light cancels the resonance to the quantum fluctuations, and that's why ultraviolet light kills cells. It separates the soul from the thermodynamic body, and that's the problem. Now here, an LED efficiency of a red light emitting diode with a small band gap, which is the red light LEDs below 2 electron volts. They with each halving the voltage, they reduce the electrical power by a factor of 4, even though the number of electrons and thus the light power emitted dropped by only a factor of 2. Decreasing the input power to 30 picowatts, the team detected nearly 70 picowatts of emitted light. Now they assume that the extra energy comes from lattice vibration, so the device should be cooled slightly, as occurs in thermoelectric coolers. Now, I do not agree with this assumption. If one must make a colorimetric experiment to validate that, and I have the assumption that there is no cooling. This small band gap, which corresponds to red light, has a resonance frequency to quantum fluctuations, and that's where the source of energy is. So this is a free energy device, basically, which with extremely small power. Mine has no economical value, but the principle, I think, is clear, and yeah, and the picture I have is that we are actually channeling energy from the 0 point energy and not from the thermal energy. Here is the quantum paraelectric strontium titanate. Here, what we see here in the middle is the perovskite structure. The black ion is a positively charged titanium 4 plus ion, and when it is in the cubic phase, then the ion is in the middle, and the ferroelectric has no charge. There's no positive or negatively charged side. However, when you pull it apart into the tetragonal phase, then the positively charged ion is either up here or down here. One can work with polarization reversal. That's how most perovskites behave. However, some perovskites are so-called quantum paraelectrics, and strontium titanate is a very well-known quantum paraelectric. And even in the tetragonal phase, this ion does not want to stay in the middle. And it doesn't stay in the middle because quantum fluctuations are shooting it around like crazy, and that's why there is no net polarization. That's why it's called a quantum paraelectric, not a ferroelectric. And now there's a very interesting experiment. If you pump the strontium titanate with a pump signal, but it needs not seconds, it needs a few minutes, as you can see. It needs about 5 minutes. And you pump it with mid-infrared light, then the material suddenly becomes ferroelectric. It's not a change in phase, or not only includes a change in phase, but it polarizes. It becomes literally ferroelectric. So this so the pump signal, it structures the quantum fluctuations within the quantum paraelectric material, and that is pulling the positively titanium 4 plus to one side, and then it gets a polarization. And now the cool thing is, you can, after 13-14 minutes, you can switch off the pump signal, and then the ferroelectric state will stay for several days. So that's like the structuring of water. It can stay for several days until it dies down. So that tells me that this pumping of a quantum paraelectric with, again, mid-infrared light, that's the window to the resonance frequency to quantum fluctuation, it structures the quantum fluctuations within the molecule and pushing the titanium to one side. So that is a polarization creation by the 0 point energy, and that's one part of the effect that we use in the ferroelectric crystal oscillator. That's the research we are doing in our lab here. And interesting is also, you can, here on the right hand side, you can put on the pump signal, you can leave it on or switch it off, it doesn't matter. In this case, they even left it on. And then besides this infrared pump signal, they are now in addition putting an ultraviolet light, and the ultraviolet light destroys the structure coming from the quantum fluctuations straight away, and that makes it again paraelectric. So, and that's exactly the same with life forms. You can kill cells with ultraviolet light because it separates the information coming from the quantum fluctuations to the thermodynamic body, meaning it separates the soul from the living body. And that's how doctors disinfect their knives and whatever they need for the operations or whatever they do. And so turquoise light down to the mid-infrared, maybe even far infrared, I don't know, that is a resonance window to the domain of quantum fluctuations, and the ultraviolet light inhibits a communication with quantum fluctuations. Here is another interesting effect that is called morphogenetic programming. Now, what is morphic resonance, as Professor Rupert Sheldrake has suggested and discovered? Morphic resonance means that the more often a certain process happens in a particular way, the more probable it becomes that this process will happen again in the same way. Now, what we have on Earth is, for example, salicin, and salicin is a molecular structure that has existed on Earth for a long time and on many places on Earth. And if you measure the melting point of the pure material, it doesn't change over time. So in 1902, 1940s, 1996, it was measured, stays more or less the same, which is what you would expect. Why? One would assume that a melting point from a certain material is a fixed physical value, and why should they change in the first place? Doesn't make sense. However, aspirin, which was made from salicin, aspirin is a new molecule, and that was new, and that was then successfully sold worldwide. And when you make a measurement of pure aspirin in 1914, then in 1932 and 1996, you will see an increase of the melting point by about 10 degrees Celsius, and that is a hell of a lot. And what happens here is that a new molecular structure radiates also into the domain of quantum fluctuations, its geometrical fingerprint. And this geometrical fingerprint structures the domain of quantum fluctuations. And then when the quantum fluctuations reach a certain density of that information, this information has a feedback loop, a back-acting effect on the molecular structure, and that changes the physical properties. That is morphogenetic resonance and morphogenetic imprint. Memories in the microtubules in the brain cells work exactly the same way. That's how memories are stored in the domain of quantum fluctuations. Here we got the same example, the same phenomenon with penicillinic acid. It was measured in 1913, 1948, and 1989. The melting point does not change, and from penicillinic acid, the dipenicillinamine the antibiotic was developed, and there's a measurement in 1949, in 1975, and 1989, and here we see an increase of the melting point of just above 190 degrees Celsius to about 210 degrees Celsius. So that is a, drastic change in physical properties, and that's how morphogenetic imprinting works. And that's also with life forms. If a certain amount of animals or humans learn a certain task, then this learning, this memory will be imprinted into the domain of quantum fluctuations, and that has a back-acting effect onto the other life forms, and then they can learn that same task in a much faster way. So that is sort of the 100's monkey effect, as it sometimes is called. So how does morphogenetic programming of space-time work? Now, repeating work processes of any kind and the appearance of new molecules program the domain of quantum fluctuations, not the thermal fluctuations, because there we have an entropizing characteristic straight away. And the quantum fluctuations are imprinted with a new geometrical fingerprint. Now, this oscillatory fingerprint is stored within the domain of quantum fluctuations. It is not stored, as I just said, in the domain of thermal or classical fluctuations. Now, how does morphic resonance work? The geometrical fingerprint within the domain of quantum fluctuations influences all quantum critical materials such as single atoms, water, and biomolecules. The effect on non-quantum critical materials is rather small on first sight, but it exists because every atom is in itself, every elementary particle is in itself quantum critical to a certain degree, because a nickel atom, if I take a volume of space that is occupied by a nickel atom, one must ask, where does the nickel atom right now have the information from that the virtual particles that creates this nickel atom right now in this moment? Who tells these virtual particles to structure into a nickel atom? That comes from the quantum fluctuations. And when you have a volume of space where there's a gold atom, the virtual particles in the quantum fluctuations, they determine how these virtual particles, the classical virtual particles, are structured, so that we see in our universe a gold atom. So, this is now the last slide of the first part of this presentation, of this two-part presentation in total. Conclusions regarding quantum criticality. All quantum critical materials have access to quantum fluctuations. That's these blue virtual particles, green, yellow virtual particles down here. And therefore, quantum critical materials cannot be described by thermodynamics only. That's important. Quantum critical materials can show the phenomena of self-organization, like biological life forms, superconductivity, superfluidity, a Bose-Einstein condensate, and they can show imprint. Information can be imprinted. And a morphogenetic field is an imprint into spacetime, into the quantum fluctuation aspect of spacetime. So we're living in two spacetimes at the same time. One is the thermodynamic spacetime, one is the quantum fluctuation spacetime. And this spacetime of the quantum fluctuation can be programmed. And this information, again, has an influence on material objects. And our memories are stored in the domain of quantum fluctuations in the same way. Now, quantum critical materials can behave conscious and highly intelligent and make dead molecules alive. As I said before, the size difference between a life form and a dead molecular arrangement is the quantum critical phase transition. Biomolecules are tuned exactly to a quantum critical phase transition. That's what makes biomolecules alive, period. So quantum criticality makes dead molecules alive. So the next question is, if quantum critical materials can make dead molecules alive, then what is consciousness and where does consciousness exist? And what is the soul and where is the soul and so on? And we will elaborate these issues in the part 3 and 4 of that series. It's 4 parts, but these 4 parts are put in 2 videos. So part 1 and 2 you have just seen, and in the next video I will present part 3 and 4. Okay, thanks for listening.